Girls, get up! It's time to work on your video!
Let's go! You can sing and dance at the same time. Yes, we're ready.
Hanford, the science nerd.
Dodie.
The mountains are icy, but they have motions of molecules. See? Even cold things have heat, such as snow and icy mountain glaciers. Oh, even they have heat. Anything with molecules has heat. It's just that molecules with cold things are moving faster than molecules with the warm things. You with me?
All right, we're going to sing this so y'all students can remember this. And I'm a great singer. It doesn't matter whether something is cold or hot. If molecules are moving, heat's something all things got. Let's sing it to that rhythm. Ready, class?
It doesn't matter whether something is cold or hot. If molecules are moving, heat's something all things got.
Very good.
Thank you. These firefighters fight fires every day. But let me ask you a question. Which has more heat energy? The match of a flame or an ice sculpture? The match is hot, right? And the sculpture is cold. They're both made of molecules, but which has more molecules? The ice sculpture. A lot more molecules. So although they're much colder than the match, they also have more heat energy. More molecules, more heat energy. Think of it this way. Suppose you're trying to take a burning match and use it to melt a whole ice sculpture. It's not gonna happen. The match is gonna run out. More molecules, more heat energy.
Hanford, the science nerd.
Dr. Doty, what do you think thermodynamics are?
Well, I think thermo must mean hot, and dynamics must mean, kind of dynamic, kind of awesome.
I do know. Thank you for being with us today. Have you ever wondered why the back or the bottom of a refrigerator is so warm when the inside is so cold? Smells like thermodynamics. The refrigerator reverses the usual particle heating process. When the water condenses and evaporates inside the refrigerator, it's basically like the refrigerator sweating. This refrigerator is plugged into the wall and it uses electricity from its power source to extract heat. Alright, now this process is super efficient. It removes up to 2 to 3 times the heat that is used to power the refrigerator. Let's pretend that these are hand warmers, not mittens, the ones that you crack and warm your hands with. The main ingredient used in hand warmers is iron. Iron rusts, and we use the power of that rust to use heat to warm our hands. Small pieces of iron are put into packs and the wrapping isolates it from any oxygen. When the wrapping comes off, the permeable membrane allows oxygen to react with the iron. In the heat packs, the iron is surrounded by a chemical that allows the reaction to go faster, and that chemical is salt. Also, carbon is in the heat pack, which spreads the heat around, and vermiculite, which keeps the heat from escaping. So the slushy filling of the pack is water and propylene, which is the polymer that keeps the water from evaporating.
And now, we give you the first law of thermodynamics rap style.
This is where my lines I begin to draw. This is the one, the only, the first law. Sometimes known as energy conservation because energy wants just some self-preservation. Total energy is the difference of 2 things. These things are important to what every day brings. The first heat transfer starts with a Q, has 3 separate forms I'll explain to you. I'll start with conduction, the first of the 3. It's all about molecular activity. Convection is next with bulk movement of stuff. Touch a hot pan once, it'll be enough. Last radiation with its photon flow. Others need a medium, but for this one, no. The second thing's work symbolized W, which actually makes sense. It's one of the few. Pressure times volume, force times distance. Finding work is different in every instance.
Back to total energy. They have three forms. You see them every day. They are the norms.
Kinetic is all about things that move using mass and velocity professors approve.
Potential energy has no movement, just height, like the top of a hill on your bike at night.
The last is internal, usually known as U. Why is that, you may ask? Well, I wish that I knew.
Total energy is the sum of these three, which equals the difference of the two mentioned priorly.
Energy equals heat transfer minus work. Now you know the first law. Sorry if this was a bit berserk.
Thanks for listening to our rap. Stick around for more.
Alright. Okay, here. So the second law states that the entropy of any spontaneous endothermic reaction is always increasing. When energy is held constant, the universe's entropy is increasing.
What is entropy?
Entropy is a thermodynamic property that is measuring a system's thermal energy of a unit of temperature that is unavailable for doing useful work.
Hey Mary B, what comes after the second law? I would say the third law. I would say yes. Yes.
The third law states that the entropy of a pure solid at absolute zero is equal to zero.
B, what is absolute zero?
Absolute zero is the lowest theoretically possible temperature.
Thermodynamics.
Thermodynamics.
Yes.
Bad memories of thermodynamics and the Carnot cycle.
P.S. When Mr. Rhodes mentioned the Carnot cycle, this is what he meant.
Thanks, Faith. The Carnot cycle is the most efficient heat engine cycle.
Fun facts!
Thermodynamics.
The mountains are icy, but they've got motion of molecules.
It doesn't matter whether something is cold or hot. If molecules are moving, heat something all things got. Can y'all sing that for me, that tune? Let's go.
It's...
Ready, class? Go!
It's not...
Alright, no.
Okay, so maybe... Do I need to walk around him? Maybe like you pop in into the camera.
Just start sprinting full force towards the camera.
Well, do I come from... Put your legs a little bit closer together. Put your legs okay.
For my lines, I begin to draw. This is the one, the only, I don't like. I'm just gonna kick my legs.
Hurry up!
I'm sorry. Go. Alright, ready?
I'm
sorry. Total energy is the difference between, total energy is the difference. How does it go with the beat? I just had it. Total energy is the difference. No.
Difference between two
things.
The first heat transfer I'll explain to you.
No?
You're gonna heat.
Last radiation with its photon flow. Others need immediate. Pressure times volume. Force times distance.
Back to total energy. They have three. I swear. I can't speak. My knees hit it.
Oh, I have to flip, don't I?
Girls.
It's not made that long, I'm sorry.
What?
Just to girls.
P.S. When Mr. Rhodes said the Carnot cycle, this is what he meant. By the way, when Mr. Rhodes said the Carnot cycle, this is what he meant. I went through it like this. Okay.
Thanks for watching. Sorry it was awkward. Bye.